Hey everybody, so continuing on with Unit 10, today we're looking at the second target. We are going to start to take what we did last unit with Unit 9 in classifying these quadrilaterals, and also we will extend 10.2 and 10.3. We'll be using area formulas in order to find the area of figures in the coordinate plane. But before we can get to area, we need to figure out how do we determine what type of figure we're dealing with in the coordinate plane. Okay, so this first part of our notes is just going to be review, so we know what we're looking for when we're going into the coordinate plane. So if you remember, in a parallelogram, we have two opposite sides that are parallel, and the opposite sides are also congruent. Okay? Angles, we don't know anything special about the angles. Yes, we know opposite angles are congruent and all that stuff, but that's not going to help us in the coordinate plane. So we're going to be looking at specifically what can help us in the coordinate plane. So with a rhombus, remember we have four congruent sides. All the sides are congruent, and nothing with the angles is going to help us. Okay? With a rectangle, we have opposite sides parallel and congruent. But more importantly, we have 90-degree angles. So we've got four congruent angles, which means that the lines are going to be perpendicular. And then in a square, remember it takes the properties from a rhombus and a rectangle, so it's got four congruent sides, and it's got four congruent angles. All right, and then we get to our two kind of special ones that aren't parallelograms. We got a trapezoid. In a trapezoid, we have one pair of opposite sides parallel. We got nothing with the angles. Okay, and then with a kite, we have two pairs of consecutive sides, which are going to be congruent, and then nothing with the angles. So a lot of what we can tell in the coordinate plane has to deal with the sides, but there is a way that we can determine whether or not we have 90-degree angles. Okay, so how do we prove that sides are congruent in the coordinate plane? Well, if you remember, in order to find the lengths of sides in the coordinate plane, we are going to use the distance formula, or my preferred method, the Pythagorean theorem. So we use those to prove that sides are congruent, because we need to find the lengths. To prove that sides are parallel, well, remember, if sides have the same slope, or if lines have the same slope, they are parallel. So we're looking for same slope. And remember, slope is rise over run. And it's going to be important. We need to know positives and negatives there as well. How to prove sides are perpendicular. We haven't talked about this this semester yet. We touched on it last semester. Opposite sides are perpendicular, which means when they intersect, creates a 90-degree angle. That's going to happen if they're opposite reciprocal slopes. So, for example, if we have a slope of negative 2/3 and 3/2, those are opposite reciprocals, so those are going to be perpendicular. Okay, so let's go through our examples. I already have these graphed out just to keep the video a little bit shorter. You don't have to watch me graph these. So graph them, pause the video if you need to graph them, and then I'll tell you how to prove what shape it is. Okay, and I've got these boxes that are going to help you because they're going to kind of give that assist to you and say you should be looking for side lengths and you should be looking for their slopes, because that's how we can determine whether we've got parallelness, congruency, or perpendicularity. Okay, so with this figure, obviously you can tell a little bit what it might be. Okay, but we want to use the math to prove it. So side lengths, AB, that one's easy because it's a horizontal line. We can just count it. 1, 2, 3, 4, 5. AB is 5 units. BC is 1, 2, 3, 4 over 1, 2, 3. So we got 4 squared plus 3 squared is equal to BC squared. So we get BC is the square root of 25. So BC is also 5. CD, we count 1, 2, 3, 4, 5. And DA, we'll notice, is up 4 over 3. So that Pythagorean theorem is going to give us side lengths all of 5. So that means we are either looking at a rhombus or a square. And I know that you can tell that these aren't perpendicular lines, but we want to prove it. Okay, so we look at their slopes in order to prove what type of shape it is. So slope of AB, rise is 0, you're running 5, so your slope of AB is 0. Same thing with CD, slope of 0. Okay, BC on the other hand, we go from, if I start at C and go to B, I go up 1, 2, 3, 4. I go to the right 1, 2, 3. So rise over run, we're looking at 4/3. Same thing with DA. So they are not, I have parallel lines. The opposite sides are parallel, but I have no perpendicularity, and I have all 4 sides are congruent. Therefore, I know I'm dealing with a rhombus because I've got 4 congruent sides. Okay, and that's it. I don't have anything about the angles. Alrighty, so let's look at the next shape. Again, you might have a guess on what we're dealing with, but let's prove it. So, AB, I go up 1, 2, 3, to the right 1, 2. So I got 3 squared plus 2 squared. I'm going to take the square root of that, and that's going to give me AB. So AB is going to give me square root of 13. You'll notice CD is the same, 1, 2, 3, 1, 2, 3, 1, 2. So that's the same. So CD is going to be square root of 13. So we know those opposite sides are congruent. Now let's look at BC. We go down 1, 2, 3, 4. To the right 1, 2, 3, 4, 5, 6. So if I take the square root of that, that's going to be BC. So I've got 16 plus 36. So BC is going to be the square root of 52. And we'll notice that DA, 1, 2, 3, 4, just double checking, 3, 4, 5, 6, that's the same. So we've got that opposite sides are congruent. Okay. Now we need to look at their slopes. So for AB, rise over run, we went up 3 over 2. So that's a slope of 3/2. Same thing you'll notice with CD, up 3 over 2. All right. So now for BC, we go down 1, 2, 3, 4 to the right 6. So that'd be -4, 6. If I simplify that, that's going to be -2/3. You'll notice it is the same thing for DA. And if you'll notice, we have opposite reciprocal slopes, 3/2, -2/3, which means that these lines are all going to be perpendicular, which means I'm dealing with 90-degree angles. Therefore, this is a rectangle because opposite sides are congruent. Oops. And we have perpendicular lines. Okay? So let's go on to our next one. Given a quadrilateral with the coordinates, what shape is it and prove it. So let's find these lengths. A, B. We go down 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So I do 7 squared plus 5 squared. And I get that AB is going to be the square root of 74. BC should be the same thing. Just double checking. Yep, it is. So BC is also going to be square root of 74, which means that those side lengths are congruent. Now AD is up 2 over 1, 2, 3, 4, 5. So CD and DA, because it's the same, those are going to both be square root of 29 as well. Now we look at their slopes. Slope of AB is down 7 to the right 4, so that's negative 7/4. BC is up 7 to the right 4. So those are opposites, but that doesn't mean anything. They're just opposites. Okay, now for CD, I'm going to go down 2 to the right 5, negative 2/5. And for DA, that's positive 2/5. So the slopes don't tell me anything because I don't have same or opposite reciprocals. But the fact that I have two consecutive sides that are congruent, this is going to make it a kite. Okay? So that is the bulk of this lesson, is given coordinates for a quadrilateral, determine what type of figure it is. But there are also these problem-solving questions where I give you 2 points and you need to use coordinate math and use the properties of the figures in order to find the other 2 coordinates. And there's going to be a couple different answers here. Okay, so we are looking to make a rhombus, and a rhombus has 4 congruent sides. Okay, so that means that they all have to have the same length. So CU, we need to figure out how long is CU. Well, it's up 2 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 2 over 9, so 2 squared plus 9 squared, that's going to be the square root of 85, which means that we need to find another combination with the Pythagorean theorem that's going to give us 85. Okay? We don't want to use the same numbers because then it would be a square. Because if we just took the slope and did the opposite reciprocal of it, that would make it a square. So I want to figure out what are 2 other numbers that I can square in order to get 85. So this is just going to take a little bit of guess and check. So we got to think of our perfect squares. We got 1, 4, 9, 16, 25, 36, 49, 64, 81. Okay? So we can already count out 2 squared and 9 squared because we've already used those. Okay, now look at what other combinations we can use that's going to give us 85. Well, 1, there's no 84. 64, there's no 21. 9, that doesn't work, so on and so forth. And you're going to get 36 plus 49 is going to give us 85. So UB, we are going to want to do 6 squared plus 7 squared because that's going to give us 85. So this is where there's a couple different things that we could do. We just have to use a combination of 6 and 7. So, for example, starting at U, I could go down 7 to the right 6. 1, 2, 3, 4, 5, 6, 7. To the right 6. 1, 2, 3, 4, 5, 6. And that could be the location of B. And then, because in a rhombus, the opposite sides are congruent and parallel, I just duplicate that slope from C. So I go down 1, 2, 3, 4, 5, 6, 7. To the right, 1, 2, 3, 4, 5, 6. And I could have that be coordinate S. Now, what I'm going to double check is if I go from S to B, is that going to be up 2 over 9? Because the slope has to be the same as CU so that they're parallel. So starting at S, if I go up 2 over 9, I'm going to get to B. So that is a possibility for our coordinates. So B would be 9, 0, and S would be 0, negative 2. So notice how it's not a square, it's definitely a rhombus because we don't have perpendicular lines there. Okay, but all 4 sides are congruent because they both are the square root of 85. and then the opposite sides are congruent and parallel. All right, so a rhombus can be a little tricky because you don't want it to be a square. You want it specifically to be a rhombus. Okay. For the second problem, though, with a rectangle, this one's a little bit easier. Okay, because we have a rectangle all comes down to the slope because we need perpendicular lines. So the slope of RE is down 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6. Down 4 over 6, which simplifies to negative 2/3. So a perpendicular slope to this opposite reciprocal would be 3/2, because I don't want to use the 4 and the 6 because then it would be a square. All the four sides would be congruent. So I want the numbers to be different, but I need those opposite reciprocals to still exist. Okay, so we could do 3/2, or let's say I multiplied it by 3. We could have 9/6. We could do a slope of 9/6, something like that. But I want to keep it on the grid, and I think the easiest way to do that is to use the slope of 3/2. So starting at E, I'm gonna go above RE. You could go below. You could go down 3 to the left 2, but I'm going to go above because I'm going to go up 1, 2, 3 to the right 2. That's going to be the coordinate of D. And then from R, I'm going to go up 3 to the right 2, and that's going to be the coordinate of S. And you'll notice this is not a square because all four sides are not congruent. But we do have perpendicular lines there because the slopes are opposite reciprocals. So a possible coordinate for D and S, D would be 2, 4, and S would be negative 4, 8. Right? Negative 4, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so again, couple different answers you could have for those last two. So on your homework, it will say answers may vary because they might. Just as long as you're following all the properties for those figures, okay? So that is the next section, which is going to be really important for the next video. So if you have any questions, email me, let me know. Other than that, you can get started working on your homework. Have a good day.